first presenter is Dr. Eki Yamaguchi, and
Yes.
their research title is of presentation title Still Bridge Without Coding and the Evolution of its Rust State by AI. I think I appreciate is the presenter present? Okay, okay. Thank you, Dr. Yamaguchi, and the floor is now yours.
Okay, can I start?
Yes, thank you. Okay.
Thank you. All right. So thank you very much for the kind introduction, and this is a subject I'd like to discuss this afternoon: steel bridge without coating and evaluation of its rust state by AI. A big problem of the steel bridge is rust. This is one of the bridges in our region that rusted very badly. Then if the corrosion rusted further, we have really a problem of the safety of the bridge. This is the truss bridge, pretty long truss bridge on the national highway in Japan, and bent or deflected out of the blue in 2007. The owner came to the site and found out a diagonal member was found severe due to corrosion, and the bridge was closed to the traffic. Even more serious problem occurred in this bridge in the countryside. It collapsed right after a truck passed in 2007. And this is the view from underneath. You can see that many steel members are corroded very badly, and some members actually gone, like in here. So it was in a really a dangerous state because of the rust development. A means of for protecting the bridge from corrosion is coating. But as you know, the coating is very expensive. About 10% of the construction site of the superstructure, and it had to be repeated every 10 to 20 years during its service period. So the life cycle cost LCC of a steel structure is said to be pretty high. Of course, people have been aware of the problem for many years, and people preparing several means against the corrosion. Another one is the weathering steel. One is the coating, and the other is another one is the weathering steel. The U.S. steel produced what they call the GOLN. This is a trademark and a weathering steel. And they started selling this steel in 1933. And in 1964, this GOLN was applied to a bridge in the US for the first time. And this is how the weathering steel bridge looks like. This is a bridge in Japan. This slide shows how the weathering steel works. This is a conventional steel, and this is a weathering steel. This is a steel itself, and this is a rust. And in the weathering steel, there is a fine rust layer between steel and a regular rust. In weathering steel, fine rust is produced on the surface of the steel. And this rust is fine, so that would suppress the development of rust, protecting the penetration of the water and chemicals to reach the steel surface, which therefore could make coating unnecessary because it works as if coating. And then the maintenance cost can thus be reduced significantly. This is an illustration how the thickness loss changes with time, changes with the development of fine rust. The speed of the corrosion loss gradually decreasing, so that weathering steel is supposed to have not necessary for coating. This slide shows how the weathering steel bridges and the look changes with time. This is one steel bridge in Japan, constructed in, opened in 1981. This is how the bridge looks like in 1982. The rust development is not uniform and doesn't look very nice, but with the time, the color changes, become more uniform all over the bridge, the girder, and it further becomes like this. And in 2004, it looks pretty good. And the bridge is still in use without coating. I believe they saved a lot of money for the painting of this bridge. On the other hand, the weathering steel does not always work as expected. This is a bridge in Okinawa area in Japan, the southern part of Japan. This was constructed in 1981. This is the picture in 2001, 20 years later. The corrosion doesn't stop and actually develop so badly like this. And this further progressed, and then in 2003, we found that a big chunk of rust fell down from the web. And in 2005, we have the holes in the web and pretty significant deflection of the web as well. Eventually, this year, the bridge was closed to transportation, to traffic. And then in 2008, still the bridge was there. And then we see this lower flange was cut because of the corrosion. So in this case, weathering steel did not work fine. Right? Oh, I can show that. You can see that the holes in the web become larger than before. So some weathering bridge was fine, in good shape, while the others are not. So we try to investigate how it actually worked inside. We conducted the field study in Kyushu Yamaguchi region. This is Japan. This area is the Kyushu Yamaguchi region. And during the period of 2001 to 2003, we went to check out the rust state of the 337 weathering steel bridges. All right, they are located all over this island and islands. The rust state is not uniform over the bridge. As you know, the size of the bridge is pretty big compared with the rust. And so we came up with the two evaluations of the rust state in the bridge: overall evaluation and local evaluation. Overall evaluation is somehow the average rust state of this in this bridge, and local evaluation is the rust state in the localized area. That's would be the worst rust state in the bridge. Evaluation, by the evaluation, we came up with a rust level shown here, from rust level 5 to level 1. 1 is the worst rust state, 5 is the finest. And you can see that the difference between them. Mostly you may recognize that the size of the rust particle is different. This is very big. It's rust layer already, right? This one is maybe acceptable, right? Rust is not that fine. This is very fine rust, and here is also. Okay, this is the outcome of the field study. Overall evaluation, we found very few bridges in bad state. Only 1% for level 2 and 1% for level 1. On the other hand, for the local evaluation, we find 90% for level 2 and 10% level 1, right? So the conclusion was at the time was most of the weathering steel bridges are in good shape, and most abnormal rust are localized, right? So weathering steel bridge are working fine, mostly in the region, although we have to be careful about the rust state in the localized area of the bridge. Initially, the weathering steel bridge were supposed to be maintenance free, but based on the reports in the literature and our study, now we believe that weathering steels are not maintenance free. And the recommendation is that we need to conduct a periodic inspection of rust state in the bridge, in the weathering steel bridge. So when you do the inspection, as we did, we classify the rust state into 5 levels, from 5 to 1. For the first stage of the inspection, we do with the size of the, based on the size of the rust. If it is very small, then it is 5, and 1 millimeter is 4, and 1 to 5, 3, 5 to 25, 2. And level 1 was worse, is worse than the formation we found. If we found the formation of the last layer, then it is level 1. As I said, this is the same slides I showed you before. So this is 5, 4, 3, 2, 1, and then they can be classified with the size of the particles. So the criterion is simple for the first stage. Yet still, the judgment is not that easy. Actually, there is always cases where we should give 1, 2, or 3. All right, and many weathering steel bridges have been constructed by municipal governments in Japan, which do not have significant budget for maintenance. Well, this is a reason actually why municipal government want to employ the weathering steel bridges. And they also lack in-house engineers. So because of this, for them, it is not very easy, even more difficult to make judgment of the rust state, evaluation of the rust state. So we thought that knowing this, or against the background of this, we started the project to develop the AI for the evaluation of the rust state. Well, I'm sure you know well, but the AI is supposed to give, we put some data and it came up with the output. And the AI is constructed by the so-called training data or teacher data. In the inspection of weathering steel bridge, we usually conduct a Scotch tape test. We adhere the Scotch tape to the surface of the weathering steel and take out the rust particles. This way we can easily find out the size of the particle, right? This case, this is an example of the Scotch tape test, and this is level 3. We can say that from this result. So we decided to use this Scotch tape test for the input data. We scanned the Scotch tape test and it came up with the image file. And this is the input data AI. And AI is supposed to give the output and then rust level for its output. But actually, this was the initial idea, the initial stage of the project. But actually, just for the maintenance purpose, we all need is to classify into 2 groups actually, because for level 1 and 2, the rust state is no good. So we have to take care of them, right? We have to conduct a further inspection to figure out what to do. But if the rust state is 3, 4, 5, the rust state is okay. So it doesn't matter whether it is 3 or 5. Anyway, if the rust state is classified into one of them, the owner doesn't have to worry about the weathering state. So instead of rust level, we decided to output of AI would be C and S would be fine, right? The relationship between rust level and AI cause is that C, if the rust level is 1 or 2, this has to be evaluated as C. If 3, 4, 5, the rust state is S, right? AI should come up with this S. But there is always the case that a decision is difficult, and we put them N, especially between 2 and 3. We have to be careful because this requires the further inspection, this doesn't. So we need to be careful, and then those rust state which are not very easy to judge, we put them as N. So if the rust state is C or N, further inspection is needed. That's our recommendation. And if it S, no further fixation is necessary. The owner just let it go, continue to use.
Dr. Yamaguchi, you have only
Yes.
1 more minute left. Kindly
How many
please.
minutes? Okay.
Okay, thank
Oh,
you.
I thought we can spend 20 minutes up to
15 minutes.
50 minutes or
Yeah,
to.
yeah.
That's what I heard. Okay.
Okay.
All right. So this is, oh, you said 30 minutes at the beginning of this session. Well, anyway, let me go. Our AI is not that, is a very typical one. Programming language is Python 3, framework of Keras, and then we prepared 9 different structures of convolution network, neural network. And to deal with the training data, we applied 5-fold cross validation. Well, this is a standard procedure, and 9 and 5, so we have 45 AIs. All right. For the training data, we prepare 1,998 images of rust state, and they are taken from 28 bridges. So this is the AI output. This is the result output of the AI calls C and S, and this is the exact rust state evaluated by the expert, right? In addition to the teacher data, we reserve some Scotch tape test for the checking the accuracy of AI. And if AI gives the same evaluation as the result, that's fine. Those are in the red frame, blue flame. So about the summation of this, no. These rust states are okay with the correctly evaluated by AI. On the other hand, in the yellow frame, the difference is observed. But if AI code decides this is the output is N, but actually it is C, then in both cases, they require the further inspection. So practically there is no problem by this difference here and here, right? On the other hand, this is the area that AI shouldn't give evaluation in this region in the red frame, because AI says this is S, so the further inspection is not needed. But actually, experts said this is N. Further inspection is needed. So this output is not on the safe side. To overcome the problem, we further apply the ensemble learning with majority vote. Out of 45 AIs, we picked based on the characteristics of the each AI, and then we picked up 5 of them, and then applied this ensemble learning with majority. And this way, the rust state that was incorrectly evaluated previously not on the safety side, now it's become 0. No energy calls now, and the classification accuracy is here. This is accurate, and 98% of the 98% of the Scotch tape test was evaluated correctly. All right. So this is all I want to say. Thank you very much for the message. AI is very promising for conducting the variation of rust tape. Sorry, this is all I want to say today. I'm done.
Thank you, Dr. Engineer Iki Yamaguchi. This is the session for question. Please, dear participant, if you have any question, please question.
Sir, I have one.
Yes.
Uh, uh, in last slide, Rust level here, I'm seeing just he shows us that level number 3 and 2, the size is same. I think is it? How can it is possible? Like 5 millimeter and 5 millimeter. How can we identify that 5 millimeter is 3 or 2? Whether it is 3 or 2?
Okay,
And
Yeah.
slide number 21.
okay. Slide number 21.
Yeah.
Yes, the criterion is not quantitative, actually. So we need 1 to 5 and 5. So there is always some, well, rust particle is not only one, there are many. So
Okay.
you have to find out on the majority of the rust particle in the
Oh.
Scotch
Got it. Yeah.
either one of them. And actually, it was a very difficult decision to make. That's why you need expertise or the experiences. So that's why you utilize the decision made by their expert and use the AI to
Yeah.
decide which is correct and then give the same result as the expert. That's why I make the giving the hard time for the local, municipal governments. Thank you very much for the question. That's very important thing.
Thank you. Got it.
Any other question from participants? Please. If the question, actually, I am sorry for that. I miss that brief biography of Dr. Iki Yamaguchi. I like to express the brief biography of Dr. Iki Yamaguchi. Dr. Iki Yamaguchi is a professor of Kaishu Institute of Technology in Japan. He is a native Japanese, but he was earned master degree from AIT, Thailand, and PhD from Purdue University, USA, in addition to bachelor degree from University of Tokyo, Japan. His expertise includes structural mechanics, bridge engineering, among others. He serves as a member of the International Advisory Committee or the Scientific Committee for various international conferences and a member of the editorial board of international journals. He is also a chair of the Technical Committee on Application of Monitoring Technology for Infrastructure Maintenance of the Asian Civil Engineering Coordinating Council, ASEC. If no other question, we want to thanks Mr. Yaki Yamaguchi for his nice presentation. Thank you.
Thank you very much for your attention and the kind introduction of chairman. Thanks.